Hello, mic test. Mic test. Mic test. Okay. It is a bit too big. Okay. Okay, so that seems to be everything seems to be set. Can you all see the display? Okay, looks like everything's set. Wow, well, today has been pretty intense. Last 2 days also. Didn't really have time to review all the technical stuff of the OBS. But anyway, I'm glad you're here. Thank you for your patience. Okay, welcome to tonight's Facebook Live, happening every Wednesday at 8 p.m. So if you haven't already, you can access our blog and download the notes. It will, for this session, it will usually be on the first post of this blog, and after you've clicked the blog, there will be an option for you to download the notes and the live stream link. Okay, so this is brought to you by Math Heuristics. Okay, a bit about myself. My name is Kevin Huang. I'm the curriculum specialist here at Math Heuristics. I've been working here since 2011, and let's just say that I enjoy where the company is headed, or even though I'm only an employee, okay, but I like the direction that the company is taking, and it gives me a lot of autonomy to explore various ways of teaching, various ways of delivery, and keep on refining my craft. Okay, so this Must Know Heuristic series part 2 is also partly extracted from the Mastering Heuristic series, written by my boss and my mentor, Mr. Sunny Tan. So this is a set of 5 books that covers different critical areas of the PSLE exam. But more than exam, it breaks down the thinking processes behind solving unfamiliar problems. And I think that's the most important part now, because more and more unfamiliar questions seem to be popping up in PSLE. So that is my personal opinion. Okay, so anyway, let's go on to must know heuristics part 2. So there's there's 4 questions, but these questions, if you look through the notes, you will see that they are rather unfamiliar to you, and it's going to be more difficult than the previous week. Okay, the first question itself is already much more difficult than the previous week. So if your child's grade is still not improving, even though he or she knows how to apply heuristics, most likely it's because he or she does not know which heuristics to use and why. So there are 11 heuristics that can be applied to primary school math problems. Let me just show it to you briefly. This part, I believe everyone is familiar. The use of diagrams or models. Okay, everyone is pretty familiar with this by now. Okay, later on I'll show you the memes if I can, okay? Stay tuned for the memes. Then the next up, you want to make a next one is on using before and after scenarios. You can either use a model to represent this, or you can use tabulation for clarity. Then the third one will be on acting it out. This is more for lower primary students to understand and appreciate the concepts that are taking place. Like, why is it that when A passes something to B, the total remains unchanged? You want to act it out to fully understand and appreciate the situation. But I also found it useful for teaching net shapes for P6. You literally cut out the shape and you fold it. It beats trying to explain the theory to a P6 student. Okay, the next step will be on systematic listing, which can solve a few unfamiliar types of problems, including some PSLE 2018 problems. Okay, I think it's question 9, paper 2, question 9, and question 17. You can take a look at those. Those are, I would say, pretty nice questions because it's very unfamiliar and requires you to look deep into several aspects. And next one is on looking for patterns. These questions came out in 2015 and 2016 as the last question of the paper. Okay, working backwards, guessing and checking, simplifying the problem, which we do all the time, and making a supposition, solving part of the problem, and paraphrasing the problem. Okay, so today I will discuss with you what are these math heuristics and why use math heuristics in problem solving. Okay, these are the types of the heuristics that are present in our primary school curriculum, and tonight we'll discuss how to zoom into the right heuristics just by looking at the keywords. Okay, that said, okay, first of all, this is not about asking you to spot question. Disclaimer, 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 this is not asking you to spot question, don't get me wrong. I never in my life I advocate about spotting question. Maths is not about luck. Okay, maths is about really understanding what's going on. So with that being said, let's cover tonight's Facebook Live 30. So I believe this will be one of the last few sessions for the P6s. Hopefully I can do one more next week. Okay? So which heuristics to use and why? Now, number 1. Andy, Benny and Charlie had a total of 864 marbles. Andy gave Benny some of his marbles and Benny's marbles increased by 50%. Benny gave Charlie some of his marbles and Charlie's marbles increased by 40%. Finally, Charlie gave some of his marbles to Andy, and Andy's marbles increased by 20%. In the end, they all had an equal number of marbles. How many marbles did each boy have at first? Okay, so let's look at what we have. There is a statement describing the before. There are 3 changes over here. And there is a final end result over here. Equal number of marbles. So when we look at this question, the first thing we notice is that the end result here is known. Secondly, by inspecting its nature, why is it that A passed to B, B passed to C, and C passed to A? This total is going to remain unchanged because nothing new is going in, nothing is going out. Okay, we did something like this last week. You can check last week's Facebook Live for that. Okay, then for this problem, I'm going to write it a bit smaller because I'm going to need the space. Okay, so here, let me just write it out. First things first, when you see that your end result is known, you want to work backwards. Now this is not an absolute rule, but it works most of the time. Okay? Xing Ling Liu are correct. Secondly, because this is an internal transfer, your total remains unchanged at 864. Okay? So based on this, because there are multiple changes, this time around it involves 3 items. Let's tabulate the information first. Okay, we know that the total here. Okay, I'll give you some time to write it out. Try to keep up. Okay, the total is always going to be 864 at every point. There's very little being said about everybody's distribution at the beginning. So the beginning point would not be ideal to start with. So let's start from the end. Okay, where everyone has an equal number of marbles. Okay, this, and this number is all going to be the same. This would mean to say that 864 divided by 3. Okay, let me take my calculator. Equals to 288. So everyone at the end of the day is going to have 288. Okay? What's next? Okay, let me get rid of this dot. Now, because we have identified that we want to work backwards, it will make more sense to read the question from down to up. So let's look at the third change over here. At the third change, what was happening? Finally, Charlie gave some of his marbles to Andy, and these marbles increased by 20%. So this would mean that at Andy at this point, okay, Andy at this point he had 100%, and now he has got 120% over here. Correct? It increased, his marbles increased by 120%. So we are going to say over here that, okay, I'm going to type this a bit smaller because I may need the space. 120% of A, or rather Andy, is going to be 288. So at this point, we want to find out what he had. He is going to have, okay, find out 1% of ND first. This would be 288 divided by 120 to give you 2.4. Okay, maybe let me just type it out for the sake of everyone. Some of you, I understand, may not be that familiar. Okay, so 100% of ND is going to be, okay, let me just space out first. 100% of ND is going to be 100 times 2.4. Yeah, this will give you 240. So at this point, we can say that ND will have 240 over here. Do you agree? Okay, Unicorn, please focus. Okay, so where did this come from? This and these marbles increased by 20% came from Charlie over here. And let's look at what this change was. Okay, for Benny, you can see that he did not experience any change during this statement. So he would have got 288 over here. He would still have 288 over here. And because we have identified that your total is going to remain unchanged at 864, C at that point would have Charlie at that point would have 864 minus 240 minus 288. Okay, if you can abuse the calculator, abuse it. If this is your paper 2, abuse your calculator. Okay, make full use of all devices that you are allowed to use. Okay, this will give you 336. Why I cannot write? Why I cannot type in there? So this will be 336 over here. Okay, so we can check that this is indeed total unchanged. For A receives 48 from Charlie. And this entire line checks out. Okay? Okay, Shivan, you got it? Yeah, I need to type it smaller because my handwriting is too big. So let's look at the second change. What was happening at the second change? We've settled this line. So let's look at the second change. Benny gave Charlie some of his marbles. Charlie's marbles increased by 40%. So if you understood the first change, this would merely be a repetition of I should say the third change. If you understood what was going on in the third change, this would merely be a repetition of the third change. Okay, so now let's look at the second change. What was going on? So Charlie's marbles increased by 40%. Means to say that over here, before the change occurred, Charlie has got 100% of his own marbles. Okay? So this would mean to say that when you increase by 40%, this would now be 140%. And hence, if 140% of Charlie is going to be 336, then 1% of Charlie is going to be 336 divided by 140. Okay, to give you 2.4 again, and then 100% of Charlie. Before that change is going to be 100 times 2.4 to give you 240. So we would know that Charlie at this point is going to have 240 over here. Okay, then this change came from Benny. Okay, now A and D did not experience any change, so this will be 240, which means to say that Benny, because your total is at 864, Benny must have 864 minus 240 minus 240. Okay, so this would give us 384. Alright. Now, finally, there are three changes. Finally, for your first change, you can see how much writing there needs to be for this question. For the first change, Benny gave Charlie some of his marbles and Charlie's... Well, let's look at the first change. Andy gave Benny some of his marbles and Benny's marbles increased by 50%. So what happens over here for Benny? At this point, there's 100% of Benny over here, and now Benny has increased to 150% of this instant that he has. So if that is the case, let's look at 150% of Benny first. This is 384, so 1% of Benny is going to be 384 divided by 150 to give you 150 to give you 2.56. So 100% of Benny would just be 2.56 times 100. Okay, so if you are familiar with it, you don't have to write all these exact statements out. You can just write 1% is something, or better still, you can just write 100% and compute it straight away. I'm writing this for the benefit of those who are maybe in P4 and still want to join and take a look. Okay, so this would give us 256. Okay, so if this is 256, Andy was the one who gave it to him. Charlie did not experience any change during this phase. So Charlie is going to remain at 240. So Andy here is going to have to have 864 minus 256 minus 240. This will give us 368. Okay, so you can check out your changes. 368 to 240. You can use this as a means to check your answer. So you have same numbers and opposite signs here. Your total is going to remain unchanged. And true enough, 256 plus 128 will still give you 384. Next up, at this point, 384 to 288, there was a change of 96. Did Charlie receive 96? 240 plus 96 does indeed give you 336. Okay? So you can see that everything checks out. You can answer now. Each boy is going to have, and D will have 368. Benny will have 256, and Charlie will have 240. Okay, and all these will be your answers. Okay? So over here, wait, you'll write this down first, then I'll explain to you. Hello, Aaron. Yeah, Ang Wei, you got it. Wait, hang on, where is it? Ang Wei, were you the one at Mrs. Ko's class just now? Jessica, you got it too. Okay, don't worry if you didn't get it on the first go. The video will be up for replay. Okay, so take your time to go through it again. And what I recommend is you print out the notes and try to go through along as I'm going along. Or either that, or you just write it on a piece of paper. Because if you just listen passively, it's not going to be very effective. Okay, Wei, I want to say thank you for your chocolates. Okay? Alright, let's move on to number 2. How many different handshakes can be made in a party of 2 children, 3 children, 4 children, and 100 children? So over here, okay, A, B, C, and D are rather straightforward, but E is the tricky one. Okay, so let's take a look at A, B, C first. When you got 2 children, hang on, my stylus got a bit of issue. Yeah, okay. So anyway, if you got 2 children, A and B, there's only one possible way for them to shake hands. A shakes hands with B. That's the end of it. Can A shake hands with himself? I mean, like, does this count as a handshake? I don't think so. Okay, the answer is no. You can shake your hand like that, but that wouldn't be counted as a handshake. A and B, so between 2 children, there's only one possible way that this can be done. A shake hands with B is the same as B shaking hands with A. Okay, it's not counted as 2, it's counted as 1. One handshake only. So for when you have 3 children, how many ways can this be done? So let's look at this. If you now have got 3 children, it can work like this, correct? Or if you prefer, I can also list it out. Okay, if you prefer, I can also list it out like this. So you see that you have a triangle over here. You have A can shake hands with C, C can shake hands with B, B can shake hands with A. You are going to obtain 3 different handshakes first. Okay? Then lastly, if you have 4 children, you can connect all these dots together and you will see that you will obtain 6 ways of shaking hands. Okay, and if you list out this is what you would have. Correct? So like what I mentioned, A shaking hands with B is the same as B shaking hands with A. A shaking hands with C is the same as C shaking hands with A. B shaking hands with C is the same as C shaking hands with B, and so on. So you can observe that on this side, everything is repeated. And if you've watched the Facebook Live on patterns, you will recognize this almost immediately. Because this pattern is 1 plus 2 plus 3. Some books will call it the triangular numbers, but it's also the sum of consecutive numbers starting from 1. Okay? You can observe that a pattern that this pattern resembles the sum of consecutive numbers starting from 1. And I do not want to consider all these. Okay, I do not want to consider all these because all these are repeated. Okay, so you can see that over here, when you got 4 children, this is a 3 by 4 rectangle. So you want to say something like 4 times 3 divided by 2 is going to give you 6. Then 3 times 2 divided by 6 gives you divided by 2 gives you 3, and so on. Of course, you can also go by that pairing pattern. Pardon me, my brain is a bit fried due to 7 hours of intense holiday workshops. Okay. So over here, that can be done. So for 100 children, you can see that this is 1. This is 1 plus 2. 1 plus 2 plus 3. So when you have 100 children, this is going to look somewhat like 1 plus 2 plus 3 all the way up to a certain number. Then the next question is, where do you stop? Okay, some of you are saying 4950, some of you are thinking that this should be 5050. So which one is it? Where should you stop? Tonight's session I think will be a bit longer. Okay, Elise is saying up to 99. Okay, so you can see over here that if you have 4 children, your last number here is 3. If you have 3 children, your last number here is 2. If you have 2 children, your last number here is 1. So if you have 100 children, there should be 99. 99 should be your last number here. And when you have this, we say that half times 99 times 100 will give us 4950. Okay, so this will give, for part D, the answer is 4950. If you try to draw out 100 dots and connect them, good luck to you. Okay? Yes, you stop at 199. Very good. Okay? So the next part here is that a total of 1225 handshakes are made in the party. How many children are there in the party? And you can see that if you try to do this by the pairing reasoning, it's going to be very hard to work backwards, and that alone is already quite difficult, and it will be even more difficult to explain the concept to a primary 6 kid. So here's what we want to do instead. We say that half times something times something will give us 1225. What we want to do instead is to do guess and check for this. So this is your number of children. Remember, according to this pattern, this is your number of children. This number here is 1 less than the other number. Okay, 1 less than your number of children. So let's try out a few things first. Okay, what's a reasonable number to start with? So you can start with something like 30. Okay, let's say you have 30 children here. Because for primary students, they have not learned about quadratic equations yet, let's not go into that. So if this is 30, this number should be 1 less. This will be 29. So half times 29 times 30 gives you 435. So it doesn't work. Then we can try out half times 40 times 39. This will give us 780. So this still doesn't work. So let's try out something, but eventually you will see that by doing this reasoning, you will be able to obtain 1225. And based on the reasoning here, this column has your number of children. So your answer for E has to be 1225. Okay, so to consolidate everything, your answers, okay, for A will be 1, B will be 3, C will be 6, D will be 4950, and E will be 50. Okay? Yeah, so this one is like trial and error. Once you understand how the pattern works, you want to use it to your advantage and do trial and error. Okay? Yes. Quadratic equations. Try not to use it. I mean, it's not wrong unless you really understand what you're doing. Stonks. Okay, later then I'll do the meme thing. Alright? Not now. Okay, got it. So, got it. Let's move on to number 3. Why is my... Okay, basically the question is asking here in number 3, in the addition sum below, each letter represents a different digit. Find the digit that each letter represents. So this is a crypt arithmetic question. Okay, the PSLE may not give you something this difficult, but it trains your logical reasoning on what can be done and what cannot be done. So when we look at this XYZ over here, now when you look at this crypt arithmetic, XYZ, each letter represents a different digit, and you want to find the digit that each letter represents. So to deal with this, now let us say that this is a 3-digit number, and you observe that when you add these two together, you get another 3-digit number, correct? You want to look at certain restrictions first. When you add x and x together, okay, maybe there is a carry over here. What can you say about the maximum value of these two x's? What can you say? No, is there... Perhaps there is more than one answer. Okay. Maximum, yes, Xing Ming Leong, thank you. The maximum of x can only be 4. Why is that the case? Because if your x is... Okay, let's say you replace this x with a 5 over here. What's going to happen? When you add up the hundreds place together, you will end up with a 1 over here in the thousands place. It's either a 1 0, or if you have a carryover, it becomes 1 1. So we know that x cannot be more than x maximum is 4. Or rather, I should say the x can be 1, 2, 3, or 4 at best. Okay? Then let us look at z, and x. When you add two numbers together, you get an x over here in the ones place. And there are two ways that this can happen. The first way is that z is 1. When z is 1, you add up together, you get a 2 over here. So x cannot be an odd number because this is two copies of something. Z is either 1, 2. Okay? Then the next possibility is that when your z is 6, if z is 6, there will be a carry over here. Or if z is 7. Okay, z is 7, you end up with 14. So 4 goes to the ones place and 1 gets carried over. So let's hold these possibilities first. Okay, let us look at y over here. Y plus y gives you y. What can this be? Okay, so Hongchu, you are correct. No, Elise, the issue is that if x is 5, you would have a 1 over here. But this problem doesn't have a 1 over here. No, z can be an odd number. Okay, two possibilities arise. Y plus y gives you y. Or y plus 1 from the carryover gives you a y in the ones place. So this will be a 10 plus a y. So if this were the case, then y would be 0. Because the only possible number where you add to itself and still gives you itself is 0. This is the only possibility, which cannot be the case. Okay, this will train your logical thinking in those true, false, not enough information kinds of questions. Okay, so the only other possibility would be this. And what is the only possible number for this? This would be 9, when y is equal to 9. When y is equal to 9, 9 plus 9 plus 1 from the carryover is going to be the same as 10 plus 9 over here. Okay, so once we've got that, we can say that x, though this z is either 1, 2, 6 or 7. We know that this doesn't have the carryover when z is 1 or 2. This happens only when z is 6 or 7. Correct? Therefore, if we know that z cannot be 1 and z cannot be 2. So that leaves 6 and 7. So now let's look at it. If z is 6, x will be 2. And if x is 2, okay, 2, 9, 6, 2, 9, 6. Let's just test it out straight away since you already have most of the puzzle solved. This will give you 592, which this digit doesn't correspond with this. So you have to look at the other one. we can say that Z cannot be 6. So if Z is 7 and this is 9, X will be 4. So 497 plus 497 will give you 4, 1 carry over. 1 plus 9 gives you 9. 1 gets carried over here. Then 1 plus 4 gives you 9. Okay? No, Jordan, the thing here is y is 9, then you obtain this 1 plus 9 to give you a 9 with a carry over here. Okay? Yep, a lot of you got it already. Very good. Isabel, Kong, Polly Ong, Jazel, you got it too. Can Z be 2? The answer is no, because this only happens if Z is to be 2, then Y would be 0, and that is not possible. Okay, so the X is equal to 4, Y is equal to 9, and Z is equal to 7. Then this would be your answer. Okay, right, I think I'd better move along already. If you need to review the logic and explanation, just watch the replay. Okay? No, 1 plus 9 is not equal to 9. It is this 9 with a carry over here. So there will be, essentially this gives you 19. When you have a 19 over here, what do you do in your addition algorithm? You carry the 1 over to the next place. Which of the 11 heuristics approach is applied here? This one is more of logical reasoning. Okay, Daniel, go. This is more of logical reasoning. Okay, then anyway, let's move on to the last number. The last question, okay, before we get too late. Now, Jack was told to number 300 blank cards from 1 to 300. How many digits would Jack have to write all together? So you have digits and you have numbers. Let me make this clear first. Okay, let's say this number 1337. This is a 4-digit number. Okay, it requires 4 digits to express out this number. So when you list out all your cards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way until like 99, then 100, 101, 102, and so on. Okay, you want to list out a few of these numbers first to get a feel of what the problem is talking about, especially when you are not exposed to this or when you are unfamiliar with the problem. Try to list out first to get a feel of what's going on. So you can see that all these are your 1-digit numbers. All these are going to be your 2-digit numbers. And all these are going to be your 3-digit numbers. Okay? I think probably by 9. Hopefully I want to end it by 9. Because I still have a lot of backlog admin stuff to settle as well. Okay, so anyway, there's a range. There's your number of pages. And there's your number of digits per page. And there's also your total digits here. We can borrow the idea of number times value equals to total value here with a little tweak to it. Okay, so here, let's look at it this way. From 1 to 9, you want to classify all of them as 1-digit numbers. So the number of pages, wait, no, I should say number of cards, because I was number of cards, number of digits per card. So from 1 to 9, there's going to be 9 cards available. Every one of these cards has got 1 digit each. So the total number of digits here will be 9 times 1 to give you 9. Okay? Okay, I'll answer your question in a while. The next one will be all your 2-digit numbers. And this is where it gets tricky. From 10 to 99. Okay? My question for you here is this. How many cards do you have? Is it 89? Or is it 90? Or is it 91? Which one is it? No, it's not over 9,000. Trust me, it's not over 9,000. Okay. Okay, so what number is this? How many? Okay, a lot of you would think that it's 89, but it's not. Okay, it's not. It has to be 90. And why is it 90? And why is it not just 99 minus 10? Now think of it this way, the number of cards here is 9. How can we obtain this 9? You can say this by 9 minusing 1. Nine minus 1 plus 1 to give you back this 9. Because if you try to do 9 minus 1 here, what is that? That is your number of plus 1s in between. That is your number of intervals. Correct? But you are you are considering the number of cards themselves. So you have to treat these like your lamppost problem, and add back in the 1 over here. So this, to generalize it, will be 99 minus 10 plus 1. And that will give you 90. You can see that over here, this part, there is only 8 plus 1s. Okay? You have to add back the first one the first number as your point. So when you have determined that your number of cards here is 90, 90 times 2 will give you 180. Okay? So I'm not going to list this part out. There's going to be 89 plus 1s. There's going to be 89 intervals. You can go and try it out on your own. And moreover, for the 3-digit numbers, you have this from 100 to 300. So by the same reasoning, this will be 300 minus 100 plus 1. You are going to obtain 201 cards. The number of digits per card is 3. You just take 201, multiply it by 3, you will obtain 603. So finally, how many digits will you have to write all together? This would be 603 plus 180 plus 9. This would give you 792. And this would be your answer. Okay? Okay, if you don't get it, watch the replay again. Okay, Marlene, you all got it? Marlene, Isin, Mala. Who else got it? Okay, those who said 90 just now, you are correct. Yeah, Isabel, you're correct also. Okay, so that's very good, at least. There's a lot to deliver today. You can see tonight's difficulty is a lot more challenging than usual. Okay, so that's why I have to take a longer time to clear it. Okay, 5 minutes to 9. Okay, so let me make this real quick. Okay, thank you for staying with me to the end. So if you want to learn more about this, you can check out our website at mathheuristics.com/learning-tools. Okay, let me just type it out real quick. For the publications. Okay. No, now where's the pin post? Pin comment. Okay, so what does it come with? First of all, it comes with the hard copy books. Okay, let me just use white. Hard copy books. Number 2, you also get the ebook version. Number 3, you'll get the mobile apps to go along with it. Number 4, you will also get the web videos to explain these ideas. Okay. You can check out more at www.mathheuristics.com/learning-tools. So let's talk about, okay, for those of you who are in P6, rest well. You will need to rest a lot in order for your brain to function perfectly or as best as you can. Okay, let's see what memes I have. Okay, wait. How can I send this over? Yeah, I should put a stonk meme over here. Then your marks go up like that. Then this guy over here, stonks. Okay, so anyway, the session is over. You can leave now. Thank you for having me. Now let's go into the memes. Okay. I don't know how to send this over. Okay, without like compromising stuff. If you have questions for me, I will answer them. Okay, hang on, do I have the access to it? Okay, someone tell me what's yeet. No. Okay, if you are not into memes, better not learn it. Stonks. Okay. Show us a meme vid. No. Gonna draw the Bugs Bunny here and say no. Hey, you're welcome, Shiwen. Now these days the memes is what? I don't know whether I can show it to you or not. Okay. I show you from my handphone. Okay, này. Okay. Okay, you can see this. Yeah. Okay. No one, the guy in a math problem, is surrounded by several bananas. And the other one is what? Okay, the other one is what? Okay, don't worry, repeat the I got scanned through all the memes before I show you all. Wait, Nah, okay, I better not show you. Not safe for children. Okay, you all can leave first. No, I didn't search up for the word math memes. I didn't search up for it. I just looked through random internet sites, YouTube channels. And stuff, okay? Hey, you're welcome, Rashida. No, whatever I see, I'm not gonna tell you what I see, to be honest with you, because there's a lot. Okay, first of all, on the internet, right, there's a lot of unfiltered content that is not safe for kids viewing. Okay, at the age of 12, you may think that you are smart enough to discern a lot of things. I would say that at 12, I also thought that way lah. Okay, it's not very nice for you to be exposed to certain things about the world yet. Okay? Yeah, I'm not going to be the one to introduce you to all of this. So whatever I show you is going to be like kid friendly. Okay? No, it is. You don't go and say we all. Only you are dirty minded, okay? Don't go and say all of us. Don't drag everyone else in. No, Area 51 kind of resurrected, but I don't think they will go and raid it. Okay, the only thing you should be thinking of eating is your math problems. Okay? So here I'm going to leave you with a little meme. I came out with my own. Yeet the math questions and make them go oof. Okay, hopefully all the P6s are going to do this. We're going to rate the exam. We instead of rating Area 51, we're going to rate exams. We're going to rate all the exam papers. Going to end this man's career. No, I doubt it. A lot of people are going to get arrested on 20th September if they try to raid Area 51. It's just not penetrable. The defenses are just not penetrable. Maybe I think I should show you all the memes from my time when I was studying in uni. What kind of memes I went through. I think I should do that. I should compile one whole set. Then you can see like what are the ancient kind of memes. Then that'll be better. Wouldn't it? No, I know. Area 51, the problem with a joke is that not many people can discern whether it's a joke or whether it's you really want to go and rate it or not. So there's a lot of speculation about what Area 51 is, but I don't know what it has. I prefer not to comment. Okay? Area 51. Yeah. So hopefully your math marks, you watch Facebook Live with me, your math marks is gonna look like this. You're gonna have this guy here in a suit with a tie. Then it's stonks. Okay, hopefully you all are gonna have this when you watch more Facebook Live with us and actively participate. Okay? So hope to see you soon. It's Kevin from Math Heuristics signing off. Yeah, I'm really looking forward to see you all next week, man. Although I'm very tired from all the intense holiday stuff. But to talk about memes here, I think it's quite nice. Okay, I think I have to end here now. Okay, good night. See you next week.